Okay, are we ready? Okay, so here is an example where I have angle, side, side, right? Everybody follows? Angle, side, side. Okay, so this is the scenario where I might have one unique triangle, I might have a no solution, or I might have two. Okay, so I'm going to start by setting this up exactly the same way as Grace did with the warm-up. Okay, I'm going to start with an angle and its opposite and set up the sine ratio. So what do I know? What two pieces of information do I know? What angle and its opposite? The A's, right? So I would set this up as 12 over the sine of 39. Okay, and I have to find what first, by the way? Angle B first, right? So this is going to be 17 over the sine of angle B. Okay, so we grab our calculator. And we're going to cross multiply this. Let's see. Come on, little calculator. Hello, hello, hello. There you are. Okay, what do I, before I start hitting anything, what do I need to make sure with my calculator, by the way? Make sure, on is helpful, but we also want to make sure that the mode is in degrees. Okay, and I will tell you that in AP Calculus, we're working strictly in radians. So they will be moving the mode back to radians, and you will be moving the mode back to degrees now. So be careful. Okay, so what am I going to multiply for my cross multiplication? I gotta go 17 times the sine of 39 in my parenthesis and divide by 12. Okay, and then the answer can't be 0.89. That's not right. So how do I find the angle? The inverse, right? Because this is the sine of B is equal to this. So now I have to do the inverse sine of that answer. And I get 63 point, let's call it 1. Okay, so at this point, what do I know? Of my three cases, remember the three scenarios? Is it creating a triangle? Yes, when I cross multiplied, I got that third angle, or the second angle. Okay, so as soon as I cross multiply and I get a number, that means I have at least one triangle. If I cross multiply and it comes up with an error, that's a no solution. Did anybody have that happen on the assignment? Okay, there was at least one problem on the assignment where you did get a no solution. Okay, so at this point, I'm going to continue on and solve this one triangle. Okay, so what can I find next? Angle C, right? So what's my angle C? I'm just going to do, oh, I have two rabbits up, because I only need one. There we go. Oh, I guess we'll go over there. So we got 180 minus that angle I just found, minus, what was the other one? 39, thank you. So anybody else get angle C being 77.9? Okay, and what's my last piece of information I need? Angle C, so I'm going to set up my sine ratio. So I got 12 over the sine of 39 is equal to C, which I'm looking for, over the sine of its angle, which we just found was 77.9. Okay, so I need to do, let's move this calculator over here. Let's see what I'm doing. So I'm going to do 12 times the sine of 77.9 divided by sine 39. Anybody get 18.6? Yep. Perfect. 18.6. Okay, and notice that when you're writing angles, make sure to write a degree symbol, so it's very obvious to me that you're writing a degree versus a length. Okay. Now, how do I know if this is the case where we have two triangles? I have no idea. Okay. So, when you thought about this scenario, let me do it again. Okay, so here's my 39-degree angle, right? This is exactly 17, and this is exactly 12. Perfect, right? Okay, so the two-case scenario, look at the angles when I have this first one. What do you notice about all three angles? Well, specifically the one that we had to find first. What was the first one we had to find? So this is 30, this is your A, this is side A, and this is B. This is B over here. So what was the first thing that I found? The angle B. So this angle right here, right? Okay, what do you notice about this angle? As opposed to, let's see if you see it when I do the other one. Ready? I'm going to do this. There's the second triangle. Exactly. The first angle comes out as acute. The second angle comes out as obtuse. How do you think I can figure out this obtuse angle to see if this exists? Okay, let me draw this on here. What's that? Whoops. Okay, so this was the first scenario, right? This angle is 39. This length is 12 over here. This is 17. Okay, if I move this in, how do I find this angle? Can I tell you that this angle right here is the same as this angle? No. Well, it makes a, yeah, but don't look at that triangle. Think about this angle over here, this red angle, this one. Okay, so if this is a straight edge, right? What do you know about straight edges? How many degrees? 180, right? Oh, so if this angle we found to be 63 degrees is the same as this angle right here, I can find the obtuse one by doing 180 minus 63. Okay, so all I have to do is do 180 minus 60, whoops, that's not a 6. Okay, I guess it's not going to erase for me, there we go. 63.1, oh my gosh. 0.1, there we go. Okay, so this is going to be your angle B, we're going to call it B prime, okay, for the second triangle. Okay, so can somebody do 180 minus 63? So 116.9 degrees. Okay, so then we're just going to solve it with the given information in my new B. What can I find next? Angle C, right? Just like the same steps as before. So now I'm going to do 180 minus 116.9 minus my given 39. Okay, what does that give me? 24.1 degrees. Okay, and then what's the last piece of information I need on my second red triangle? The side C. Okay, so I have to set this up as 12 over the sine of 39. I can still use my given. C over now the angle is 24.1. Okay, so cross multiply that and tell me what you get. should be less than 18.6, right? Because it's a shorter length. 7.8. Okay. Is everybody okay with that? Okay, so I will let you know that this case where you have two triangles is very rare, but you might see it again.
How do we know?
Possible. Okay, so anytime you're given the angle, side, side, I'm not going to say it, but you should go, oh my gosh, wait a second.
Pain in the angle side.
Pain in the, yes, pain in the angle, side, side. Okay, you have to check for a second case. Okay, if it's not a second case, then what will happen is when you cross multiply, it'll give you a no solution. All right, we good with that? That was fun, right? All right, let's do law of cosines. Ready? I'm going to have you guys write down these formulas. Okay, so the law of cosines. Okay, so again, we are solving a oblique triangle. Okay, but this time we're given different information. Okay, if you happen to be given a side, angle side, so two sides here, with an angle in the middle, side, angle, side, you can use one of these three formulas. Okay, write this down, start in your notes, highlight it. What do you notice about the three formulas? They are exactly the same. They do come from a Pythagorean theorem, though. Okay? It just depends which side you're trying to solve for. Okay? So notice, as you're writing it, start to notice the pattern. If I'm looking for side A, you have a squared equals the two other sides that are given. They're added and squared. And then you subtract 2 times those two sides times the cosine of the angle. Are you guys writing this down? Write it down. Write it down. Yep. Write it down. Now notice that this triangle specifically is labeled ABC. What if you have like XYZ? Okay. If you have trouble, just replace the X with an A, Y with a Z, and a Y with a B, and a Z with a C. You know what I said. I said that right, actually. So now the nice thing with law of cosines, there's no two triangle scenarios. Just do it.
But it's still a side.
Yeah, but not the bad word. It's different. It's got to go around the triangle.
Well, how do you know? Oh, never mind.
Oh, I'll show you.
I got it.
Okay, so for my example, I have two sides, right? But this is a side angle side instead of a side side angle.
What do you mean?
Because see how I don't have an angle and its opposite? I don't have two A's, I don't have two B's, and I don't have two C's. I cannot use a law of sines. So if I cannot use a law of sines, then I must use a law of cosines. Okay, are we ready to solve this one? Did I give you enough time to write that all down? Good? Okay, so which piece of information must I solve for first? Okay, I'm looking for the side C. Okay, so see how they're all equal to sides on our equation? Okay, we're looking for a side. So look at this triangle. So I'm going to just draw a triangle. This is not drawn to scale. A, B, C. So my A is 12, my B is 18, my C is 33. Do you see how it's a side, angle side? All these three things are right next to each other. Okay, the first thing I have to find is its opposite side. Okay, so here we go. It's going to go. We're using the bottom equation, the c squared. C squared is equal to, what's my A? So I got A squared plus B squared minus 2 times A times B times the cosine of 33 degrees. Okay, now let me show you how you type this in because it can be tricky. If you don't do it correctly, you'll get the wrong answer. No, stay over here. If it'll let me turn it on. Turn on. Come on. Ah, there we go. Okay, ready? Here we go. 12 squared plus 18 squared minus 2 times 12 times 18 times. I don't have to because it's going to do order of operations and I know that multiplication is going to multiply first. Times cosine of 33 degrees. Do you see how I typed that all in one line? I didn't use any parentheses. So I got an answer of 105. Is that the answer? C. Yeah, remember that this is c squared. So my last step is to square root. So I now have to do second square root. I'm going to go up and steal the answer, hit enter, and hit enter. Okay, so 10.3. Everybody okay with that? Okay, so how do I continue solving this triangle? I have C. Okay, yeah, exactly. Now I can use the law of sines. Okay, so I can set up, I have an angle and its opposite. I have the C's. So let's set up 10.3 over the sine of 33. Should we find A or B? Angle A or B? A. So we're going to go 12 over the sine of angle A. So when I type that, I'm going to type 12 times the sine 33. Hit enter. And then I'm going to divide by 10.3. So the answer is, oh, it's not 0.63. That makes no sense. So what do I need to do to find the angle? Inverse, right? Second inverse. Do you guys know that little trick where you can go up and steal the answer? Just use your arrow keys. Okay. It's a good trick, right? So what did I get? 39 point something. 4 degrees. Okay, so the last piece of information I need is B. So how can I find B really easily? Yeah, subtract from 180. So what's 180 minus 33 minus 39.4? I'll let you guys do that one. It's going to be big. 107.6 degrees. Easy peasy? Do I need to do another example like that? Pretty easy? Okay. All right, so round 2. Maria's been dying for this case. Side, side, side case. Okay, write this one down. If you have 3 sides, you can also solve a triangle. Also using the law of cosines. So write these 3 formulas down. And as you're writing, do you happen to notice anything? They're all the same. And if you compare it to the last three you just wrote, they are the exact same formula. You just simply solved for a different thing. Yeah, so they just solved it. So technically you could just write down one single equation. But it's kind of nice to have it solved for the thing that you're looking for. It kind of saves you time. Okay. So what do you notice about the top when you're looking at this? If you're looking for angle A, what side do you subtract on the top? Your A. That's how I always remember it. You always subtract the side that's opposite of it. And then when you divide, you always divide by 2 times the 2 that you added. Okay, so that's something that you can memorize very easily. All right, am I good to go? No, I still see people writing. Good? All right, so here is my example. I have 3 sides. We're going to solve for what first?
C.
C. We're going to solve for angle C. Perfect, okay? So I'm going to use that bottom formula.
Can we solve for angle A?
You can choose whichever one. Yep. You could do A, B, or C. Okay, so if we're going to do C, it's going to go the cosine of angle C, which we don't know yet, is equal to A squared plus B squared minus C squared. Interesting how that's like a Pythagorean theorem, right? Interesting. So interesting. Divided by 2 times 15 times 21. All right, are you ready for this one? How do you type this one in the calculator? This one also must be typed correctly. Okay, are you ready? I'm going to type this all in one line, if that's okay with you guys. I'm going to do the top in parentheses, and I'm going to do the bottom in parentheses. Okay, so I'm going to go top 15 squared plus 21 squared minus 29 squared in parentheses, divided by, also in parentheses, you don't forget the parentheses on the bottom. It's very important. If you don't do that, you'll get the wrong answer. 2 times 15 times 21. And I get, what? Negative point, did I screw up? I haven't screwed up yet. Don't shake your head at me.
You have to divide by the cosine.
Yeah, remember we're doing the cosine of the angle. So what's my last thing I gotta do? Inverse, right? Okay, so I gotta do the inverse of cosine. Anytime you're ever finding an angle on the calculator, you always do inverse. No matter what you're doing, if it's laws of sine, law of cosine, if it's SOHCAHTOA, doesn't matter. So inverse cosine of our little number back there, I get, whoa, 106.1. Anybody else get that? Okay. All right, now what? Okay, so how would I solve for the rest? Can I do law of cosines? If you like law of cosines, you could continue using law of cosines and find another angle doing the same thing. Or if you prefer law of sines, you can do it that way. Which one do you guys prefer? Law of sines? Okay, so then if we do law of sines, we got to go 29 over the cosine of 106.1. I'm going to go for A first. Sine of A. And I'm going to trust that somebody in here can type that in. Oh my gosh. Thank you for catching that mistake. It is a sine. I think I wrote cosine because it was a C. And I just went with it. Should be a sine though. Thank you. 29.8. Okay, and then we can easily find angle B by just doing 180 minus the other two. $44.1. Perfect. Do I need to do another example of that? Pretty easy. Not bad? Okay. All right, the last part in this section is formulas for finding the area. I'm going to give these to you guys because they are literally a plug and chug. The hard part on it is figuring out which one to use, but I wrote above it like what you would need. I don't know why I have ones and twos, but if you have a side angle side, you can use that first formula. Oh, I see why I did that way, side, side. Okay, so write this down in your notes. You need to be able to find the area. Okay, so the nice thing is that this works for any equation, or any triangle. Excuse me, not any equation. Bless you. And this actually holds true for right triangles as well. Although right triangles are easier because you would just do 1/2 times base times height, but if you wanted to have more fun, you could use these other ones. Okay, so on number 2, is everybody okay with Heron's formula? That one is so awesome, he named it Mr. Heron. You took credit for it, Sir Heron. I don't know him, but he made that formula. So notice on this, you have to figure out what the S is before you can plug it into the area formula.
What's that?
Okay, so the S is if you add the 3 sides together and divide by 2, that gives you your S. And then you can plug it in to that equation. Yeah, so make sure you write that. That's all, this is one formula right here. So it's a little tedious, but we have fancy calculators that can handle it. Okay, so once you have that written down, your assignment is 28 through 48 by 4s. Don't let that be the hard part of the assignment.
What?
Counting by 4s be the hard part.